Good morning, everybody. My name is Vijaya Kandel. I'm an iOS engineer at Zalando. For the last 1.5 years, I've been researching on different topics, including static dynamic dispatch, generics programming, and then leading to coroutine and then functional programming. For the last 6 months, I've been working on Haskell in the nighttime, not at the daytime, okay? And today I'm going to, from my experience, try to solve the problem we've always had in the imperative programming paradigm. And by the end of the talk, you will know two things. And I guarantee you, you will understand one thing. And you can brag about it. OK, here we go. The problem, OK? We've all seen this kind of code, the networking code. And when we start something simple, we put a to-do and we then build on top of that. That's OK. But the problem is, with this data task, it has the completion parameter. There are 3 parameters on the completion block. And all of those are optional. So if you count how many choices you have to make, it's like 2 to the power 3, that's 8. So you potentially could have 8 different kinds of checks. Okay? And I don't think you would want to repeat that again. Second, what if you have another network call that you want to do after the first one? Now you have inside, target inside, and you call callback hill, but that's not the problem. Okay? And again, you forget to handle the error, or you don't. And third, the compiler is not always your friend. Sometimes you have to be smarter than the compiler, okay? Now I want you to spot a problem. There's a problem. Either 1 or either 2 is a problem. What's the problem? Yeah, right. So what is the problem? Can you say out loud? Right. But the compiler does not enforce you that. And we want our program to have a true type declaration, okay? The second guy will fail sometimes. I mean, if you pass 0. Now, these are the problem. You want to be able to compose, divide and conquer. That's the fundamental rule we've been talking about, right? So let's say you have 2 async tasks. You want to do this. You want to be able to compose these 2 things together. And while you compose, you want to have the error handling mechanism. And you should not forget to do this, or handling errors should not make you hard to compose things. And you want to have true type signature so that you're not lying to anybody. So these are the problem, and we will solve those, not with the approach we know how to do, the imperative approach, but with a functional approach. And we'll come back to Swift. It's not we are going to write in Haskell, okay? And in the end, we will verify these 3 steps. All right? So we live in a world of choice, and our choice might be right or choice might go wrong. It's always the case. So the main theme of the talk is how do you handle things that could potentially fail. That's the main theme, okay? And we are going to see this with these 3 points. Now, just a quick reminder, we all shipped great software using imperative programming. We like it, and it's not a bad thing at all. But there is another thing, the functional programming. You might want to take a look at it, get inspired, and then come back and apply the same techniques. That's what we're going to do. We should not be obvious to what's out there. I mean, oblivious. OK, so here's a simple game that we're going to play. This is called Mad Adam. So basically, we are going to do a calculator game. So it's like M is for multiplication, addition, D division. But we will assume for the talk, Swift does not have optional. And I will tell you why, OK? Ready? Swift does not have optional, OK? So we will roll a dice, and that is going to be the input. So this is a simple function. Multiplication is you pass 1 argument. We will randomly get the second argument, and we'll do that. Addition, you pass argument. We do the random for the second guy. And here's the division that you saw early. Now, the same problem, right? It has a probability that it might crash when random is 0. Everybody on the same page, right? And when you crash, you don't want to have a crashy program. But let's assume we'll succeed on this step. So let's go through the Mad Adam game, OK? So first, I roll a dice. I put the input to multiplication, then get that result, do the division, do the addition, and you get the result. But now the problem is if you put this thing in a loop, let's say 1 to 10, there is a good chance you will crash when the random for division is going to be 0. So a way to improvise is on a division function. Let's say we don't want to crash, but we want to report what went wrong, right? When random is 0, we could return 0 or -1 or null if you were in Java, okay? But that's an invalid case. 5 by 0 is not equal to 0 by 5, right? We should not do that. So let's try to throw an error. And a quick way to improvise is return a tuple. And when something went wrong, you provide -1 and what is the error. When everything goes right, you provide the right value and the error with no error. A stupid idea, but could work. But then there is two things. The choice of this tuple is a bad choice because you could pass a good value, not -1 value, and an error. What does that mean? Right? Now you have more burden on the client side. So let's fix that by saying, okay, I want something like either I want integer, either I want error, not both at the same time. So let's say maybe int, and on some, this is a disjoint union. So maybe int will have a case where it can have integer or where it can have nothing. All right? Let's try to generalize this. Say maybe t. We make it general so that t can be anything. So we say maybe some t, none. Let's say we want to have what went wrong, right? A little bit more descriptive error. So let's say maybe you have something. If it fails, it will give you an error type. And at this moment, it doesn't look like a maybe, but it looks like a result that you might have known, right? So this is the result. So now the declaration looks like this. The result says, the result of int means it could have an integer, it could have an error, but not both. And that's a good choice, and it's true. Now, this is going to be slow in the beginning, I will warn you, but it builds up, okay? We will be talking about very high-level things towards the end. So this is a build-up. You need to know what a result is. It's a box, okay? Not a concrete value. And it can either have a concrete value inside or a error inside, okay? We are not talking about what t is, we are talking about what box is. Now, when you add, in this case, in our case, multiplication produces a concrete int, but division does not produce a concrete int, it produces a box, right? So how do you compose? Let's do the Monadic game again. So in this case, when we are done when we apply div, we get a box of int. Now, the other guy, the addition, works on a concrete value, not on a box value, right? So what we do, we open the box, check if there is a value, then pass it in. If there is not a value, then do something else. Is everybody on the same page? Right? It's fairly straightforward. So you open the box, you pass it if there is something. So this is what we are doing with the switch statement, right? And then, see, we had 2 division. Now we had 2 switch. And I'm still not handling the error, which I should. But let's take a moment. If there was 10 division in a row, then you would have a nested switch case, right? And you might not have 10 division, but think about it, you have it. So now let's try to generalize that one. What is repeating? It's the switch. It's the box, opening up the box and seeing the value, right? So let's try to generalize this opening of a box and passing a value. So this is going to be unwrap. Box analogy works fine. So the first guy would be the box value. That is the result type. And if you have something in there, you want to apply a transformation, right? Because box has a value, either has a value t or error. And the transformation goes from t to u. That means if you have something inside the box, then please do apply the second guy, right? And then you want to return u, let's say, just to begin with. But then what happens when you have a box that has an error? You cannot make a concrete u out of an error, right? Everybody on the same page, right? So we cannot do this. Now, that's why I don't want you to think about optional, because you could do that, but we'll come to that. So u is not a right choice of the output. So what do? You box it up. So you apply something. If you get a concrete value, you put that in a box and return the box. It's a gift. So it's a result type of u, right? And if it fails, you pack that in a box and then send it. So now you at least somehow give the error to the second guy, which is good. Now the program becomes this. Now when we divide, we get a box, we unwrap, and then we apply the add, and then this returns you a result of int, which is a box. Great. Now second, when you apply div again, what happens? You have a box, you apply div, you get a box of a box. Now if you had 10 divide in a row, then you get 10 box, you know. It's a lot of manual work to open those box. Now, my arrows are coming late, anyways. Okay, so what is a box of a box? Now we want to see that, right? If you have a result and it inside has a result, it can either mean the box has error inside or the box has a box inside, right? So you can flatten those two layers and get it down to one so that you only say, okay, let me open the box and see, and then provide only one box, not two box, right? So this is just a flat function. You unwrap two box and put it into one. So how does flatten work? You pass a box of a box, right? If there is some concrete value that is going to be a box, you return that box. If there was an error, you pack the error in a box and return. Boom. Now you can see, like we're using unwrap here because this got the flatten here because this was result of result, right? Everybody on the same page until now? Flatten is understood, right? Okay, so now we have a monad for ourselves, and I will explain what a monad is, okay? So if you see some type with map and flat map, probably they are a good candidate for monad. I don't say I guarantee they are monad because there are other laws that you have to concern with, but probably it's a good choice that the thing is a monad, okay? Flat, map, and map. Now maybe you've been seeing this on the internet saying if you have a flat map and map, it becomes a monad, but we'll see why, not what. So a monad is a contextual type, okay? It represents something went wrong or something went right. Rather than giving you int, it gives you, oh, something maybe inside that or maybe not. So it's a contextual type that provides linear binding, composition, and error propagation. Now we'll see that. But map is taking a concrete function that returns t to u and wrapping up in a box. Then flat map takes a t to u, use flatten inside, and then returns you one box. Okay? Good. So this is the same thing in a code. Okay, now I will come to optional. Now optional has flat map and map, and it can be treated as a monadic type because it provides these two functions, and it's a enumeration type. And then there is collection. It also has map and flat map. Now why is collection a contextual type? Because it can be either empty or it can have some amount of items, right? So the failing case is the empty case in this case. Now try-catch can be implemented as a way of result monad, but the Swift try-catch, you throw and then you catch on the other level, but it could be implemented in terms of result monad. I don't know about the intrinsic compiler things, but it can be. So let's play the Metadam game again. So see, we divide, and then we do add, then is a map, okay? Did I tell you that? So map then is just the wrapper on map. So let's say this. We do then, which is map, we do flat map, and then we again do then, and then do then. Now, do you see any like nested things here? Like, do you see switch statements going all over the place? And do you see somewhere, do you think there is being error handling code? Nothing seems to be involved here, right? And it's like as if you're reading something. But both of those things are happening behind the scenes for you. So now we want to verify our three things. So true types, we did a result int, which is true for this function. So whenever you see a type, it has to be true for every input possible. Okay? So that was the easy part. Error propagation. Let's say the first division fails. Okay? Let's say. But we will go through the rest of the chain, and when we end up, we will so the first division tried to divide by 0. Did you see that? So it threw cannot divide by 0, and then we did all the thing. But in the end, we get Okay, we have an error in this case. Something went wrong in the first place. Now, if you have a problem in the middle somewhere, you again get an error, right? And that means you don't care where the error happened, but in the end, you will get the error if it happened. If it doesn't, you're happy. Now, let's take a look at the composability. The first one was like a lying type, the divide type. We had like a sequential thing, which was nice. On the other hand, we did this monadic type, and then, again, now we have this pure monadic computation, right? Now, this is also composable, right? It reads nicely. We didn't sacrifice anything. So now the interesting part comes in. And what about the async task? What about network calls? This was the simple case, right? Can we somehow do the same generalization on the network APIs? And that's the interesting part. Now, we have a synchronous monad. I will not go into the implementation details, but the thing are the same. You have map, you have flat map, right? So there is a promise type. You can call future, deferred. In Haskell, this is called IO monad, right? So the completion is going to be now what promise T represents. So let's say you fire a GET request. Now, the T represents what is the eventual value that you are supposed to get. Let's say you are asking for a JSON. T is going to be the JSON in this case. But it doesn't mean that it will happen immediately once you call this, okay? So there is a little bit of completion chaining going on, but it's really simple. So you have a task, and then you have to call the completion when you are done. And then we will chain this thing together. Now, what a promise is, let's see how a promise represents to the analogy of a box. So promise of a T is going to be something when done will have either T or something else, or error, right? But when done, big part, it's not going to be immediate. So it's like a task will call into T when it's done, and then you know you got something later down the road. Now, map is the same thing. It takes concrete T, returns you a concrete U. But how do you chain with the promise T? When the T is done, it will call into your map function. It will somehow encapsulate that. To see how it actually works, you can take a look at the code, which is just like 30 lines. So what is a flat map? It takes a concrete value, transformation of a concrete value, and then returns you a promise. Now, like we did earlier, this could be like a promise of a promise U. Now, we do the same flatten. It's the same way. Now, you flatten that down and return just a single layer of promise, which is this. It's very hard to explain because of the nested completion, but I hope you get the idea. So let's make use of this promise, okay? So see, I have this network. I mean, this is just a wrapper around the network. So I say get, and then I get a promise of result of data. What does this mean is when I'm done executing this URL request, I'm going to get a result box because the network could go wrong, right? Then I need an error. I cannot do promise of data because it's not guaranteed to be data all the time. Does that make sense? So I use result that we built earlier inside. So when this is done, I will get result of data. Then I can do something. I can check the value of the result type. So now I can do first call, and then I will provide a then. And when I get the result of data, I will do bind with data to string and return that. And this returns a promise of string. Then in this case, I just skip the string. I return another URL. And this bind is a flat map. And then I do, with this URL, I do a get inside a bind, right? And then when I do then, I get the result data from the previous network. And then I can do something on that. And remember, I have to do execute, and I will tell you why. When you create a promise, it's not going to be executed immediately. It's just a way of abstracting the nested callbacks, and it will build a giant expression for you, okay? It's just a huge expression, block, and then you have to eventually call execute to fire this thing. that gives you nice properties like you can copy promise, you can duplicate it, and then these two things are separate. And promise is implemented as a struct, so that means you get copy on write. So this is the promise, and if I decide to say, okay, on the network I go and say, okay, let me always make it act as if something went wrong, right? So I provide a promise with a failure. Now let me check the error propagation. Now I do this, the same code as before. I will fail here, right? When I call then, it's going to get, and then I'm going to get a error. So it should go through it, but then in the end I should get the error that was thrown by the first call. And this is what I get. But from the code, it doesn't seem that I'm explicitly making use of error handling logic, right? So it's just like you declare something and then go on step by step. If something goes wrong, happy. If not, you get what went wrong. It's not like obscure. So, okay. And you can compose this network inside of a bind is going to be dependent on the outer promise. So if that completes, then that guy will be fired. And after that completion, we will go to the next then, okay? It's like you have a guarantee of order of execution. It's not like random things going on. Now let's take it a step more ahead, and let's see how we can improvise UI animation. I mean, animation is basically a sync task, right? So you have a completion block when it completes, and then you can chain other animation on that completion block, which is essentially the same as a sync callback hail. So I have a small wrapper on UI view, and the wrapper will produce a promise of a UI view. Does that make sense? If everything goes right, I will have a UI view inside of a promise. If something goes wrong, in this case, nothing will go wrong. But if it goes wrong, I will get an error, because promise has error, right? So I can start with a red view, and then I will say promise of a view. That will give me a promise of a view, and then I bind other animations that I want to do. Now it's very declarative, like you say, okay, I want to do for 2 seconds, I want to make it green. For 2 seconds, I want to make it purple, and for 3 seconds, I want to make it orange. And the order is guaranteed, and you call execute because a promise is a big expression. And that brings you this animation. Did it stop, by the way? No? Okay. There is red, green, and then the orange, right? Now, maybe we can also go on and generalize some of the repeating parts. And I'm going to have a extension, which you don't really require, but I'm just going to express how expressive you can be. So it again returns a promise, but it does the animation inside. Now you have something like this. So there is nothing saying that there is going to be a completion, there is going to be a nested callback, and what if something goes wrong? It's already baked in. The only thing that you have to do is understand what it is, and then make use of it, as if it will be handled for you. And this is the beauty of Monad. It's there for you, right? Rather than you being explicit and saying what to do all the time. Again, this has the same result. How am I doing on time? Oh, I'm doing great. Okay, so this has the same result. Now, a good programmer is someone who looks both ways before crossing a street or doing something. So I presented you how to do something on a functional way, but you already knew how to do that on an imperative way. Maybe you can take this home and then maybe try to apply it, but you should not neglect something just because you don't know. Maybe there's a better idea on the other side. Okay, I expect a lot of questions. Thank you very much.
Hi there. Nice talk. My question is why, from a design perspective, why didn't you parameterize the type, the error type on the promise? Yeah, so then you could specifically say no error, so you'd know that you could never fail.
So basically, I thought about it, and promise by itself does not have any error reporting mechanism, right? It only says, I will give you a promise of a UI view. But then it is your decision. Do you want something to be reported back to you? If you want, then you can use promise of a result of a data, or promise of a result of T. Does that make sense? So you can use promise as you're doing synchronous tasks that will never fail. But you can also do the same with promise, saying tasks that might fail. In that case, you will wrap the inner type with a result. And result has this error propagation mechanism. Now, this is two things at one. You compose and you also get the error propagation, right? More questions, please.
Sorry for leaving you without a microphone, but I have an unusual question. What was the most complex functional thing you've been doing with Swift? Because like those things are pretty simple. They are not simple for imperative programming, basically, but for functional programming, they are very simple. And for example, we have such library called SwiftZ, which includes a lot of different functional approaches. So what was the, yeah, I guess so. What was the most complex thing you adapted to Swift? Yeah.
I mean, SwiftZ has a great support for all these kind of things, which is great, and you're using. One of my colleagues also uses SwiftZ, but not in our project, in a different project. And they talk about monads and monoids all the time. The most interesting thing that I ever did with the functional concept of Haskell coming into Swift is how you can model functor, monoid, and monad as a protocol. It was quite confusing to me because you have to go with these associated types, and then there is the compiler magic that lets you do model this functor properly, but I don't know how that works. Maybe that's just a hack at the moment. Besides that, to come back to your questions, I'm not using functional stuff all the time on my project, but the basic thing that I want to deduce to people is that why don't you use flat map? Why don't you use map? For example, if you have an optional, people are used to doing if lit, right? And then do a transformation if there is something. But you could do the same with map. And people really don't know. I mean, I found people not knowing there is a flat map on optional, which does the extra layer, right? And the tiny bit really helps you understand what's going behind the scene. And I think if everybody agrees and tries to do something like using all the provided tools we have, that is a good point. But I haven't done any spectacular thing in Swift coming from Haskell. Thank you for your question. More questions, please. Really? Did you understand Monad? Okay.
First off, I'm an Android guy, so maybe this is a dumb question, but is there something like RX Swift? Because this reminds me a lot of RX Java in design. Is there some difference here between this and like RX?
Okay, yeah, we do have RX Swift, and I think this reminds more of a promise kit than RX Swift. And I tell you a story. Well, I started my implementation of promise kit before I did functional stuff, and it was really nasty because I had to do this casting and magical things just to make it work. But what I was missing was the fundamental truth behind how things work. And to me, that's the greatest thing that functional programming teaches. I mean, there are certain kind of law. If you obey them, you can do those repeatedly. And we've seen this with the result and promise, right? And this promise is not reflective of RX Swift or Promise Kit. They have their own kind of implementation, but it kind of does on the client side the similar thing. But we do have. And SwiftZ, by the way, is like a full-blown functional implementation in Swift you can use. More questions, please. Okay, I have a question from, yeah, that is drawbacks. You have to understand, that's the drawback. You know, it's not that easy. You know, just to wrap your head around this nested completion block is really you have to be twisted a little bit for a little bit time. So besides that, it's really tough to get the truth right. What? Yeah, I just merged this promise into our standard library. It took like 2 weeks for people to review and then understand, and I had to do a lot of this instrumentation saying, okay, it doesn't leak memory, it worked great, and I'm going to replace promise kit with this 30 lines. So yeah, I have to fight with my colleagues. Yeah.
Okay, so you say that you merged that into a standard library for the team. What can you say about the test-driven development then? Does it help? Does it get in the way, or any other knowledge that you have to know about testing this kind of code, because it's not imperative, and there is some magic going on inside? So yeah, test.
So before answering that question, let me give you 2 points, okay? If you have an enumeration with map and flat map, that is the only requirement you have to do to make a monadic type. Not a pure monad, but a monadic type. And then you can repeatedly work on other layers without thinking about them, right? So coming back to your question, is TDD going to be hard after you use this kind of things? I think not much. But certainly, to be able to use, I mean, I have a team of 10. And I have to convince them, I have to make them understand what this is before they actually make use of it, right? And it's always a trade-off, like, maybe I will go and use this, but maybe other person will not. They will, again, go on the imperative side, and you have two things in the same project. But TDD is not going to be hard. More questions? Did you understand monad? Really? Yeah.
Can you just explain why you used then and bind instead of something more, I don't know, a map or a flat map? Just because it seems that the then it sort of tells me that it's going to inject a side effect and not really return anything. It's just again a design choice.
So like I said, I implemented this after getting inspired and then sad by promise kit implementation. And it has then, and it doesn't have bind, by the way. Bind comes from Haskell, but then comes promise. I think then read more nicely because it's like people are used to, okay, I do this and then it goes, right? Rather than saying map. So it's the same story like optional. People know there is optional. They don't know there is map and flat map because it's not obvious what map does in that case. So I think this is a sort of choice that I made, but you could go with map and flat map. Okay, then do we have more questions? Otherwise, I will give you some reference to where you can go from here. Yeah? Does everybody understand monad? Okay. Let me give you some reference which are really interesting that I think will make you a better person. So there is the resource paper on monad, which is really nice. It goes through all the benefits that monad has, but it's not easy. I tell you this, okay? The fundamental truth is always going to be hard. And there is this railway-oriented programming, which is awesome. Awesome, you know? The guy talks about all these things with pictures of railways. And there is this, if you want a really voodoo functional programming guy, then you can watch Dr. Bartos. I cannot pronounce his name. He has an amazing series of category theory lectures. He goes through all the set, union, blah, blah, blah. It's really amazing. But you will not remember anything. And you can go check out my blog. I've written the same thing, a little bit more descriptive there. And I also try to write something when I have time. Okay? So I don't want to show you a disclaimer. I had to, so because it's from Zalando. Okay, thank you very much, guys. I hope you enjoyed.